Hello everybody. The first video of the term will be about the structural systems of floors, and I'm going to draw here some typical floor structural system drawings, plans and sections. And what I want is I want you to prepare those drawings and upload it to the homework that I will open in Innova before next week. Okay, so I'm going to give you enough time for preparing those. Firstly, you all know that from the previous week's lecture, we have got two main types of materials for the structural systems of the buildings. The first type is reinforced concrete, and last week during the lecture I have told you that reinforced concrete floor systems can be categorized into 5. These are RC slab floor, RC flat slab floor, RC hollow slab floor, RC ribbed floor, and RC ribbed, I forget a D here, and the final one is the RC waffle floor. Okay, we have talked about these. These are the most common types of reinforced concrete floor systems. There is not a rule book about these. Different professionals, different civil engineers may name them differently, or different architects may also make this categorization differently. The important point is how we use different types of reinforced concrete structural system to pass larger span in a more cost-effective way. So from this floor type to that floor type, the cost-effective span passing capacity increases. Okay, and in steel structured floors, okay, we have got basically two types. Okay, the first type is the most common type. We have talked about it during the lecture again. It is called as steel concrete composite deck. Okay, so these are all of these, both these things that you see here, these names, and the names that you see here is used to generate floor plane. Because you know that during the lecture I have explained it in detail that the main structural system of the building, consists of column, beam, and shear columns or braces. If it is steel, it is braces. If it is reinforced concrete, it is shear column, which makes the building resistant against dynamic loads like earthquake and wind. Okay, and the second type of floor generation method that we use in steel structured buildings are using floor panels. Okay, but mostly we use this type. Okay, so from now on we are going to work on a rectangular shaped plan. Okay, it is a single floor plane which is supported with columns on the corners. Okay, so we have the first column here, and the second column here, and the third column is here, and the final column is there. Okay, until the end of this video we are going to use this as our building, this plan sheet. Okay, 4 columns in 4 corners, and the borders of floor is represented with these single lines. Okay, so let's start with slab floors. let's draw a line here. Okay, and 1 slab floors. Okay, so in slab floors, what do we have? Let's take a different pencil. We have got main beams, rectangular in shape. Usually rectangles are dropping down from the ceiling. Okay, so they are standing perpendicularly in order to use the moment of inertia of them. Okay, so in plan we connect with 4 beams, 4 columns to each other. Okay, and all of these are going to be named as reinforced concrete main beams. Okay, we have got another reinforced concrete main beam here. Okay, and we have got reinforced concrete columns here. Okay, and these columns carry the main beams, and the main beams carry the floor slab made of reinforced concrete. Okay, so that floor slab is located here. That's why here I'm going to write that this is floor slab that we have there. Okay, let's immediately draw a section passing from here and there, and let's name it as AA section. Okay, so what we do in architecture, we firstly draw the elevation lines. These are the elevation lines representing the columns. They continue up and down. This is an intermediate floor, let's assume. Okay, I put here dashed and dotted lines to represent that columns continue upwards and downwards. Okay, and then I am going to put here the beam, which is something like this, and I am going to put the slab, and here is the other beam, and here is the floor slab. Of course, as we have a beam in background, I'm going to draw another line there. And now, in order to make you understand it clearly, I'm going to hatch it like this. Okay, and this is our first floor type. Okay, it is very cost effective for spans up to 5 meters. Okay, and let's draw a detail of this part in a larger scale. So what we have a beam like this. Okay, and this is the column in the background, and that's the beam in the background. And let's draw here a dashed and dotted line. Let's name this as, okay, A. Let's not use only A in our entire drawing. Okay, let's name it as C. Okay, so now this is a detail C. Okay, and what about the dimensions? Here it is 15 centimeters. Here it is 30 centimeters, and this height that we have here is, okay, going to be around 50 centimeters. Okay, let's again hatch it in order to make you understand clearly. Okay, in normal conditions I hate hatches, but in order to make you understand, I will now. So what I will do now, I'm going to turn my paper 90 degrees and pull it slightly down, and I'm going to put here another section mark. Okay, and I'm going to name it as BB section, and what I will do is I am going to draw the second section of mine here. Okay, so something like this we have. Okay, all dimensions are same, the previous one. Okay, here are the dashed and dotted lines, which represents that these continue up and down. Okay, and let's write the name of it here. This is section BB. Okay, and let's hatch it also in order to make you understand more clearly, like this. Okay, and let's add some arrows and write the names of these pieces. And this one here is RC beam on elevation. Okay, we have got RC slab here, RC beam on elevation there, and another RC beam there. Let's turn it back here. Let's write the name of this section also. This is AA section. Okay, and let's write that this is structural plan. Okay, so this is the first drawing that you need to do. You need to draw it including the detail as well. Okay, on a single A4 page. That will be the first drawing that you have to draw until next week. Okay, let's pass to a new page, and this time we will try to use it more efficiently. Let's turn it this way. Okay, the second floor that we are going to work on will be hollow slab floor, no flat slab floor. RC flat slab floor. Okay, let's draw our same building here. Okay, again, a building which has got a single rectangular floor, and let's have our columns in all four corners of this rectangle. Okay, and what I will do, I'm going to pass over these lines and make them slightly more thick. Okay, and now I'm going to start writing names. This is going to be reinforced concrete column, and then we have got reinforced concrete slab here. Okay, and the difference of these floor types is only the absence of the beams which are connecting the columns to each other. We have again talked how it works during the lecture. Okay, what we will do, we are going to draw an AA section here. Again, let's draw our columns here. Okay, let's assume that it is an intermediate floor again. We are learning the structural systems of floors. Okay, so let's use all flats, intermediate floors here. Okay, and this will be how my floor slab seam. Okay, I'm going to convert these lines into dashed lines. Okay, and then I'm going to hatch all here. Okay, and I will write here AA section. Okay, and I'm going to draw a detail here. That detail will be, the only thing that we are going to have is a very thick slab which is being supported by our column in the background. Let's extend it slightly. I'm going to feel more comfortable that way. Okay, let's put here a dashed and dotted line again. Okay, and what I will say is I'm just going to draw here, okay, 25 centimeters. Okay, so we have got pretty thick single slab, and the slab itself is going to compensate the absence of the beams dropping down from the ceiling. Okay, so let's put an arrow here and write that this is reinforced concrete slab. Okay, and let's put another arrow here and write that this is reinforced concrete column. Okay, like I did a couple of minutes ago, I'm going to turn this upside down and I'm going to put here another section mark. Okay, and what I will do is I'm going to draw a very similar drawing, section drawing. Like the previous one, and I will hatch here, and underneath it I'm going to write BB section. Okay, and this is again RC slab, and we have got RC column here. Okay, let's continue with the third type of reinforced concrete floor system. The third one is, okay, I guess hollow slab floor. What do we have in hollow slab floors? Now we are trying to pass a larger span, as I have told during the lectures. In slab, wait a second, there is a problem I guess in the recording. One minute please. Yes, this is much better. We are trying to pass a larger span, like 7 meters, maybe 8 meters. In that case, what we need to do, we need to increase the thickness of concrete in a flat slab floor, for example. But increasing the thickness is going to increase the total weight of the floor tremendously as well. So what we are trying to do, we are trying to find a way of making the floor much lighter. Okay? And also, as now the thickness of the floor comes something around 35 centimeters, maybe up to 40 centimeters, what we need to do is we need to decrease the total thickness of the floor. Okay, that's why we are not going to use the beam vertically, we are going to use the beam horizontally. Okay, what means that we are going to have these columns here. We are going to tie those columns to each other with main beams. Okay, and these are our main beams. Don't hurry up and draw, because we are going to erase some parts of these drawing, these lines, these inner lines. And now we have got beams connecting columns to each other. Okay, be careful. So two beams can be placed like that in between two columns. Okay, centered, the columns are centered, or alternatively you can also place them not in a centered way on top of the beams as well. Okay, so both ones are going to be appropriate. Even in some projects you will see that. Okay, the telephone has rang, that's why maybe in the video you may find some inconsistencies. So what we have got 4 columns on 4 corners. We are not talking about the shape of those columns or direction of those columns. They are vertical load bearing members at this stage. And let's say that for all of them, the sizes of them are something around 40 by 40. Okay, for this stage it will be enough. Okay, and now what we have got main beams. These are flat main beams connecting columns to each other. Let's immediately start drawing the detail of this part. Okay, not that part in fact. In fact, we are going to draw the detail of the section. So I just hurried. Sorry about that. Let's erase this. Okay, and now the span that these beams are passing are up to 8 meters. Let's say that it is 7 meters in this example, and we do not want to increase the total weight of this floor. That's why we want to have a layer of concrete on top of these beams, which will be around 7 centimeters. Okay, but that 7 centimeters of a slab of a plane made of reinforced concrete is going to bend so easily. That's why in order to support it, we are going to add some secondary beams parallel to long main beam directions. Okay, like these. Okay, and the final one is here. So here is the part that we are going to make some erases. Okay, we are going to erase these parts. Don't forget that when you make reinforced concrete, touch to reinforced concrete in reinforced concrete structures, they become a whole. We accept them to work as a whole. That's what is good about the reinforced concrete material. Okay, now we are going to draw a section from here. Like in the previous ones, we are going to name it as AA. Okay, so like in the previous ones, we are going to have our columns here. Okay, and let's put dashed and dotted line to represent that the columns are continuing upward and downwards. Okay, and we are going to have our flat beam here, something like this. Okay, and then we are going to have our layer of concrete there. Okay, and that's the other side of the beam, and I will draw very faint vertical lines here which are representing the joints of our hollow bricks or hollow blocks. Okay, now what I will do is I'm going to erase some lines here. Okay, I am trying to convert them into dashed lines, and let me hatch the reinforced concrete part of it. It's something like this. Okay, don't worry, maybe this section seems slightly not very alike with how I explained them in the lectures. The real unique shape of the hollow slab floor will be understood when we draw our second section. Okay, so we are going to draw our BB section here. Okay, and I will start drawing my columns here and there. Okay, my dashed and dotted lines. Okay, representing that this is an intermediate floor, column continues upwards, downwards. And here is my main beam again, like this. Okay, and here is the top layer of floor, like that. Okay, and then we are going to go some here and drop down our beam. Some more and our rib. Some more and another rib, or one more rib, and the final thing. And these spaces I'm going to put X's there in order to represent that those are solid but very light pieces. They are hollow blocks. Okay, and like I did on the AA section, I'm going to erase some parts of it. Okay, and now let me hatch the reinforced concrete part of it. Here is our reinforced concrete hollow slab floor. Okay, and let's write some names. This one that we have here is reinforced concrete column, and this thing that we have there, it is a reinforced concrete main beam. When you watch the recording of the lecture, you will see that I have defined main beams as beams which connect columns to each other, and we have got reinforced concrete ribs here. Okay, and I have explained the difference between rib and a beam. The span passing component, if is smaller than 30 by 50, that will be called as ribs. If they are 30 by 50 or more, we are going to call them as beams. Okay, and what do we have here? These things that we have here are hollow blocks if they are made of AAC, or hollow bricks if they are made of clay soil. Okay, let's turn it back there. Okay, and let's draw the detail of here. Okay, let's say that it's a C. The C detail will be something like, okay, let's extend it some more. This is my main beam. Okay, this is the beam, and a fainter line here which is representing the hollow brick row. Okay, and I will hatch here in order to represent that it is entirely reinforced concrete, and here is my column in the background. Okay, and dashed and dotted line here, and dashed and dotted line here as well. Okay, let's talk about some sizes. Okay, so here we have got a thickness of around 35 centimeters, and here we have got a width of around 70 centimeters. Okay, and we are passing a span up to 7 meters. I already wrote it there. Okay, and what we have this layer of concrete there that is around 7 centimeters. Okay, now what I want to do, I want to turn it like this once more, and I want to draw another detail, detail D. This time, this is our column, this is our main beam. Okay, this is my layer of concrete, this is my rib, and it continues like that, and here are my blocks. Okay, and another one going like that, again dashed and dotted line here, and I need to raise this line or turn it into a dashed line, it is hindered by the beam now. Okay, and I have got my reinforced concrete part here like that, and again this size, it was 35 I guess in the other detail, and this was 70. Okay, these are something around 40, and these are something around 15, 1.5, and again this is also going to be 7 centimeters. Be careful, the ribs that we have here are going to be measured like this. Okay, they are 15 by 35. Okay, and the beam also includes the reinforced concrete plane on top of it as well. Okay, so it is not 35 plus 7. 35 also includes that 7 centimeters layer of concrete on top of it as well. Okay, so this is how we make reinforced concrete hollow slab floors. Now let's pass to a newer page. New page, and let's continue with the fourth type of floors, which is going to be a ribbed floor. Let's write 4 here, ribbed floor. RC ribbed floor. Okay, so again we are going to have our reinforced concrete rectangular plane, okay, which is our floor. Let's assume that we have got same columns. Okay, as now the span will be larger, maybe the column sizes have been increased to 50 by 50. We are not interested on that too much at this stage. Okay, what I will do is let's write that this is 9 meters now. Okay, a very long distance, and this is the second part of it, and let's assume that it is 7 meters. Now really a floor of around 50 square meters, a very large span we are talking about now. What we will do is we are going to tie the columns to each other like we tie the columns to each other in slab floors. Okay, this time as the span is too much, we do not want to lose the moment of inertia of our beams. Okay, we place it vertical. Okay, not flat beams like we have in hollow slab floors. Okay, and what we do, we connect the, okay, this is maybe too near. Okay, I'm going to erase it like that. Okay, and I am going to 7 meters divide it into 3 equal pieces. Okay, and I'm going to add 2 beams here. Okay, they are not ribs anymore, they are beams. Okay, and on top of them, what do I have? I have all covered with a plane of reinforced concrete with a reinforced concrete slab in fact. Okay, so you will understand it. Okay, but firstly, these are RC main beams connecting columns to each other, and this is also RC main beam as well, and we have got columns in the corners, RC columns. Okay, and let's repeat it once more. This is also RC column. Okay, and we have got RC secondary beam here. Oops, secondary beam. Okay, and on these parts we have got RC slab. And this is also RC slab as well. You are going to understand it better when I draw the section like we did on the previous ones. Okay, I'm going to draw a longitudinal directions section firstly. Here is my column. Here is the other column. Okay, so these lines are representing this and that column. Okay, and let's draw our dashed and dotted line here to represent that column continues upwards and downwards. Okay, and then we are going to have our large beam here, and we are going to have a slab of 15 centimeters, 1.5. Okay, and we are going to have our large beam here as well. Okay, and from beam to the other beam, be careful, this is important. First, I'm going to increase the thickness of this column in order to make it understood better and more clear. Okay. What we will do is, as you see, this secondary beam that we have here is tied to main beam. Where is the main beam? Main beam is here. So I'm going to start drawing the secondary beam from the main beam to the other main beam. And as you see, the secondary beam hides the column backwards. That's why I'm going to turn, okay, I'm going to erase these lines, okay, which is representing columns, and then I'm going to transform them into dashed lines here, okay, because column is hiding them. Okay, so what do I have now? I have got my reinforced concrete slab here, which is 15 centimeters minimum, and it is being supported by my secondary beam made of reinforced concrete. Okay, let's write the names. This is reinforced concrete main beam, that's reinforced concrete slab, and this thing that we have here is reinforced concrete secondary beam. And of course it will be good if we write column. Okay, it's maybe the most important component when we think about structural safety. Okay, let's draw the other section as well. Okay, so the other section will pass from here and there. It will be named as BB. Okay, and this is BB section that I have here. Okay, and here are my columns, my other column, my main beam. Okay, like that. It continues, comes here, and I have got, okay, let me step one step back, okay, and draw the secondary beam slightly smaller than the main beam. And this is how it will be seen. Okay, and now the main beam is in the background. That's the main beam. Okay, be careful this time. I am not going to tie the main beam to the other main beam here, because main beams are tied to columns. Okay, so I end it here and there. Okay, and what I will do is I'm going to erase this line and that line there, and I'm going to transform them to dashed lines like this. Dashed and dotted line here, dashed and dotted line there, dashed and dotted line here, and one more there. Okay, and I will hatch the reinforced concrete part of it. Like that. Okay, now what do I have here? I have reinforced concrete main beam. I have reinforced concrete slab. I have a reinforced concrete secondary beam here. Okay, and this thing that I have there is the reinforced concrete main beam in parentheses on elevation. Okay, I see it on site. Okay, and this is the column. Okay, that is RC column. Okay, and that's all, I guess. Still, I want to draw here as a detail. Okay, I'm going to draw that detail on the lower side of my page. Here is my main beam. Okay, and I will go like this. And I will do something. I'm going to erase this part. And I'm going to put two dashed and dotted lines very close to each other in order to represent that. I cut some part out of there because I want to fit my drawing here. That's what we architects do in order to fit some large drawings into small spaces. Whenever something continues, okay, we just can cut some parts of it. This is the column and this is the main beam on elevation. So let's continue this line until there. And let's hatch this thing that I have here. Okay, and what about the sizes? This size is now something around 70 centimeters. This size is maybe something around 40 centimeters. Okay, and the distance between the main and secondary beam is maybe 2 250 centimeter or even more, maybe 300 centimeters. And the size of my beam here is something like 30 by, from here to there, something like 50 centimeters, like a real beam that I have in reinforced concrete slab floors. And I guess that's all. Oh no, that's not all. Okay, the thickness is also important. Now we need to have a thickness like a real slab that we have in reinforced concrete slab floors. I am not very comfortable if I don't write a section here. We need to name our drawings whenever we draw something. And this thing that we have here is the structural plan of a ribbed floor or a beam floor system. Okay, ribbed floors or beam floors. Okay, beam slab floors. Beam slab floors. Okay, I guess we should pass to the final type of our reinforced concrete floor systems, which is the, let's turn this upside down, there's some stain there, but it's not important. The fifth type of floor system, reinforced concrete floor system, is RC waffle floors. I have already explained, if I'm not wrong, the reason of waffle floors or coffer floors. I remember I drew something like this. Okay, and I had told you that it is a pre-manufactured bucket made of plastic, which is used as the formwork of waffle floors. They are called as coffers. In Turkish, it is kaset döşeme, and these are coffers or kaset in Turkish. What do we have again? And these floors are very appropriate for very large span square forms. Okay, that's why I am drawing a square form now. And I have got my columns in four corners like I did in the other floor systems. Okay, and I have got main beams. Okay, but before talking about main beams, let's say that this distance is around 12 meters to 12 meters. Really 144 square meters of an area we are talking about, and it is really a very large span. So imagine the entire house of yours doesn't have any columns inside itself. Okay, and what I will do is I'm going to divide it into 11 equal pieces. Okay, yes, like that, I guess it will be fine. And I'm going to draw lots of parallels now. Okay, I will raise this because I couldn't fit or follow them. Okay, so they are more like random lines now. Okay, but don't hurry to draw them. Okay, because I'm going to make some raises. Okay, once we are finished with this direction of beams, I will start putting the beams on the counter direction, opposite direction. Okay, here are they, here they are. Okay, like this. Okay, so I am forming square forms, as you see. Okay, maybe I did one less or one more, but it doesn't matter so much. The aim is making squares there. Okay, and what will I do? I am going to erase these lines, intersection lines, but it's going to take lots of time. So instead of erasing them, I'm going to try to pass over and make the beams more darker and make you understand like that. Okay, do you see there are lots of squares here? They are coffer places, in fact. Okay, like this. They are all squares. Okay, here I am drawing freehand. That's why I am drawing, trying to be as fast as possible, because I know that you get bored when you are watching the video, and I want you to watch the video entirely. I don't want anybody to skip forward, okay, the video. Okay, I know that it takes some time. If I will find time for editing, I'm going to double up the speed here. Okay, it is really very boring, but I will finish it anyway. Okay, so we have got lots of squares. Okay, probably you have understood why we name it as waffle floors. It looks like the waffles that we eat. My hand starts hurting now. Okay, we are about to finish. Okay, I'm very happy. Last 4 and 3, 2, 1, and we are finished. Okay, so this is our floor. This is our waffle floor. Okay, and its section is going to be more impressive. Okay, let's draw a section from here and let's name it as AA section. But firstly, this is a structural plan of a waffle floor. Okay, and here is the section of it. Now the columns, let's say, has increased to 80 by 80 maybe. I have got my first main beam here, and then my secondary beams are like this here. Okay, I have got lots of beams. Okay, 1 by 1 or maybe 2 by 2 squares we are talking about. Okay, and now that this section is passing from here, that beam, that secondary beam on elevation, is again going to hide the column. Okay, so what I need to do, I need to erase this line again, and I need to draw it with dotted lines again. Okay, and let me hatch it. This one seems slightly small. Okay, really I am not very satisfied with the quality of the drawing. I could draw it better, but unfortunately I don't know why I am in a hurry now. No, just joking. That's all, of course. That's all right. Okay, that's what I do like to do. Okay, I'm going to enlarge this slightly more, like this. Okay, let's draw here as a detail. Okay, let's name it firstly. That is an AA section. Okay, and now it will be seen something like this. This is my main beam. I'm going to use the same trick. I'm going to cut it from here, sorry, and I'm going to draw dashed and dotted lines here to represent that. Floor continues that way, but it is too long and I do not want to spend unnecessary space for it. That's why I cut it, it means. Okay, like that. And here is my column. Again, more dashed and dotted line we have here and there. Okay, and I am going to have the secondary beams on elevation. I need to extend this dashed and dotted line until there. Okay, and I will hatch all this thing that I have here because they have been cut by the section plane. Okay, and now the final thing that I'm going to do is transforming this line into dashed line like this, and I'm going to add dashed lines here as well. Okay, because columns are continuous components from start to end. Okay, and I will draw another section from here, but now what I will do is I'm going to turn it like this. Okay, it's BB section now, and what I will do, I'm going to write BB section here as well. Okay, you do not do that, just copy this and draw it here as well. Okay, which means that no matter from which direction you cut this floor, you are going to get the same result. I mean the same section. Okay, that is the 5th drawing you have to draw before next week. And now let's try to draw a steel floor system. Okay, and the first type is going to be steel floors. Now we are looking at, or floors in steel structured building. And the first one is going to be named as steel concrete, composite, deck type of floors. Okay, almost everything will be same with the previous ones. Okay, what I will do is I'm going to draw a rectangle here. Okay, the only thing maybe which will change is going to be the shape of my columns. I'm going to have my edge profiles here. These are my edge profiles, which are columns, and now I need a pencil with a smaller diameter. Okay, and what I will do in order to make you understand it more easily, I'm going to erase the border lines of my floor. Yes, that's it. And I will erase this thing here as well. Okay, and now I'm going to tie these columns to each other with my main beams. Okay, so we have talked about it. I'm not going to explain in detail. I'm asking questions and I would like to hear it. What is this, ladies and gentlemen? That is a steel column. And what section of steel column are we talking about? We are talking about an H section. Okay? And what about this thing, ladies and gentlemen? That's a steel beam. And what section of a steel beam we are talking about? We are talking about an I section. Okay, typically I sections are for beams and beam sections are for columns. Okay, and we want to have a steel concrete composite deck type of floor, which means that we need to use a steel trapezoidal sheet. Okay, and we know that they can pass maximum span of 2.5 meters. And let's assume that the distance from column to column here is 7 meters. And let's say that on the other direction the distance is around 6 meters. Okay, I know that ratios or proportions are not saying that, but let's believe in that one. Okay, as this is 6 meters, firstly, the first rule is secondary beams are usually parallel to long main beam. Main beam. Okay, that's an important rule that you need to do. Okay, and let's put asterisks here. Okay, and what we will do, maximum 2.5 meters. The long distance, large span is here, so the secondary beams will be on this direction. And on that direction, the span is 6 meters. If we just put a single secondary beam right in the middle, there will be 3 meters of span, which the steel trapezoidal sheet need to pass. Okay, that's why, which is not possible. I need to reduce it to a distance, a span lower than 2.5 meters. That's why I need to add 2 secondary beams. Okay, so first secondary beam and the second secondary beam here. Okay, and then what will I do? I am going to do a couple of things. Now maybe colors will be alright. Okay, so firstly what I need to do is I need to surround my main beams with an L profile. Okay, because after I will place the steel trapezoidal sheets in their places, I'm going to cast concrete and I don't want that concrete to flow outside. Okay, and what I will do is with orange colors, okay, I am going to represent my steel trapezoidal sheet. Okay, so these lines that I draw here are representing the fold lines of my steel trapezoidal sheet. Okay, so let's write it here. Okay, let's write it with a pencil. Okay, this is steel trapezoidal sheet there. Okay, and then I am going to use Okay, let's use blue. I'm going to use my blue pen to put some dots here. What are those dots representing, ladies and gentlemen? Yes, you are right. Okay, they are representing shear studs. What is shear studs used for? They are used for welding the steel trapezoidal sheet to the steel main and secondary beams, and they are also used for making concrete steel trapezoidal sheets and beam working as a whole. Okay, now the blue hatch that I use here, the brown hatch that I use there is going to represent the topping concrete. That I have there. Okay, and this is my steel secondary beam. We forget about it. Okay, and what section is it? It is an I section. Okay, and let's draw the AA section. Okay, this is a structural plan, the name of the plan. Okay, and here is my column. What I will do, I'm going to draw the flange of my H profile, and I'm going to draw some dotted or dashed lines there to represent the web part of it. Okay, and then I am going to draw here my main beam profiles like this and like that, and I'm going to tie them to each other in the background with main beams, main beam on elevation. And then I'm going to draw a slightly more thick line. Now it is representing the secondary beam. And now that there's the secondary beam, I cannot see column anymore. The secondary beam is hiding that. So I need to transform here into a dotted line. And now what I need to do is with pink color, I am going to draw my L profiles. Okay. And then what will I do with my orange color? Where is my orange? Oh, this is blue. Okay, orange is here. I am going to draw my steel trapezoidal sheet. And over the steel trapezoidal sheet, just a second, I hurried too much. Let me finish the steel trapezoidal sheet firstly. Okay, and over the steel trapezoidal sheet, what will I do? Okay, I will cast concrete like this. Okay, and concrete is going to fill all this space. Okay, and what do I forget? I forget about drawing dashed and dotted lines here, dashed and dotted line there, dashed and dotted line here. What about this thing that we have there? That is steel main beam on elevation. Main beam. It's on elevation. I see it. The section plane hasn't cut it. What about this thing that we have here? That is steel secondary beam. As I have space on the component, it will be better to write the name of it there. And what about this thing here? That is steel main beam. This time it is in section. Okay, what about this thing here? That is the steel column. Okay, and what about this thing here? That is the topping concrete. And the orange thing, let's put an arrow here, and that is the steel trap sheet. Okay, let's draw a detail of here, and let's firstly write the name of this section, AA section. Okay, and this is the detail C. Okay, so what do I have? I firstly have my main beam here. Okay, and then I have my secondary beam here. Okay, the top flange, bottom flange of it. Okay, let's try to make this be seen more realistic, like that. Okay, and this is the elevation of my main beam. But of course, main beams are not going to be tied to each other. They will be tied to columns. Here is my column. It continues upwards like this. Okay, and let's color match everything with each other. This is my L profile here. Let's make it slightly more long. Okay, and I have my steel trapezoidal sheet here, like that. And I have got my, I know that I didn't draw the shear studs. Okay, this is slightly smaller than I need to draw. Okay, so please dismiss this line there. Okay, I need to make it more thick. Okay, like this. That's concrete. Okay, let's talk a little bit about the maybe with blue, with dotted lines, I can draw the shear studs here. Okay, like that. Okay, and the shear studs are here and there in this drawing. Okay. Yes, I guess we are finished with it. Okay, let's talk a little bit about dimensions. This is an edge profile of 30 by 30 maybe. This is something around 30 again, and this can pass a span up to 6 meters. The height of this is maybe something around 26 centimeters. Okay, and the main beam is also 30 again, and the thickness of concrete here is 7 centimeters, and thickness of concrete here is around 14-15 centimeters there. So here the height of the steel trapezoidal sheet is something around 8 centimeters. Okay, let's quickly turn it this side and draw a BB section here. Okay, so what I will do is I am going to draw two lines. Now no dashed line in the middle of it, because I see, in fact we can draw two lines here to represent the flash thickness of steel material. Okay, and again we are going to have our steel main beam here, and the steel main beam on elevation, and the steel secondary beam is here. Okay, and the steel secondary beams is preventing us to see the column in the background, so let's convert them into a dashed line. And over them, what do I have? I have my L profile. Sorry, I made a big mistake, so we need to erase it completely. Okay, because I was drawing the same section with that I have here. I totally forget about the direction of my my secondary beams. Okay, so this one, column, they will be almost the same. Okay, the only change is going to be the main beam is also on this direction, but you see the section plane cuts the secondary beams now. Here are my secondary beams. Be careful please, this is the correct one. The previous thing that I have erased was wrong. Okay, and what am I going to have here is I am going to draw my L profiles there, and immediately I am just going to draw my concrete layer there. Okay, so we draw it like we are cutting it from the lower level, from here. Okay, we see concrete entirely. Okay, and with orange color, okay, you know that I represent steel trapezoidal sheet. It is here, and the top line of my steel trapezoidal sheet with dashed line, I will draw it here. And again with dashed lines, let's draw a couple of shear studs. Here are the shear studs. Okay, and what we need to do, we need to put dashed and dotted lines here and there. We are going to put 4 of them. Okay, so this is steel column, steel main beam. This is steel secondary beam. This is topping concrete, like the topping of a birthday cake. birthday cake. Okay, and what is this that we have here? Okay, that is still main beam on elevation. Okay, and I guess that's good. Okay, so what I will do is going to be the second type of floors in steel structures, okay, with floor panels. But I'm going to show, or I'm going to talk about a unique type of them, okay, press stress precast 2-min press reinforced concrete floor panels. Okay, that is the panels that can be used, but we don't use it so much because they need a crane. Pre-manufacturing something is always more expensive, and as you need a crane and maybe a more experienced workmanship, the cost of it increases. Okay, but everything is almost same. So what will we do? We are going to, okay, draw our floor again, borders of floor. Again, we are going to have our edge profiles. Once we draw the edge profiles, let's erase the borders, okay, because you know that the eye profiles, beam profiles are going to be placed center to them. Okay, of course we do not leave it like that. Okay, we extend the floor to somewhere there usually. Okay, but that's the subject of a later stage, I guess, so I'm not going to explain it today. Okay, and now the system ends. Okay, this is the time where we will start to use our pre-stressed or precast floor panels. So I remember I have talked about them in large scale. They are something like this. Okay, there are reinforcement bars inside it. They are more like cables which are stressed before we cast concrete. Okay, and they are really very long, something like that. Okay, and now let's talk about the sizes of them. Let's assume that this is 6 meters here and it is 5 meters there. So what we will do, we are going to take a floor panel of around 15 to 20 centimeters in thickness. Civil engineers need to calculate them, these sizes of course. Okay, and this length that we have here is 6 meters, and this width that we have here is around 60 or 120 centimeters. Okay, and what we will do is we are going to take them and place them right there. Okay, of course in the corner points we are going to cut them. Okay, so maybe it will be better to draw them with colors. Okay, so these are my pre-stressed floor panels. Okay, just placing them one next to the other with a crane. It's a very fast construction, and I do not play with the dirt of in-situ concrete. Okay, and on top of these, in order to make them become a whole, okay, what we do, we firstly place some reinforcement bars like this. We cover the entire floor with reinforcement bars. Okay, and then okay, we cast concrete above that. Okay, again this is like a topping concrete. Okay, let's draw the section of it now. This is my column, my other column, my main beam, my other main beam, and I draw them with blue. Be careful, I was about to forget the main beam. The main beam on elevation is there. Okay, and here is my precast reinforced concrete floor panel, press stress one. Okay, if it is not press stressed in this height, you can never pass that much of a span. Okay, and I will draw dashed and dotted line. Okay, and I draw a section. This is a structural plan again. This is a section, and let's draw a B section here as well. B and B. Again, these are my columns, and that's my main beam. Okay, and that's the main beam on elevation, and here are my those holes are there to decrease the weight of the floor panels. Those are hollows, in fact, like the hollows in a hollow slab floor. The only function of it is making it more light. Of course, we forget something in our AA section, and it is this topping concrete that we have here. Okay, so it is making the system as a whole. Okay, and inside that topping concrete, I'm going to draw with brown dots. We have got reinforcement bar. Okay, and let me turn it this way and quickly take my pink color again and draw the topping concrete here. Okay, and with dotted lines, again I want to represent the reinforcement bars inside. What is this that we have here? That's the steel beam. I'm not going to call it as main beam because there aren't any secondary beams. Okay, this is steel column. This is steel beam on section. The other one was on elevation. What about this thing that we have here? That's the RC floor panel. And this is the topping concrete. Okay, and this is topping concrete again. So please you spend more time and draw better drawings than I draw here. Okay, and that's the final drawing that you have to draw until next week. And now I want to draw another thing. Okay, I am going to draw a schematic expression of a building section. Let's assume that this is ground level. Ground level. Okay, and let's say that we have designed an apartment building like this, and the ground floor is slightly inside, and we have got two basement floors. Okay, 1, 2. I will erase this ground line because now we have our building there. Okay, and I'm going to make my ground floor slightly elevated than ground line. This is first floor, second floor, third floor. Okay, do you understand? This is a section drawing. Section drawing. Okay, so this is ground level, -2, -1, ground, 1, 2, 3 levels we have. Okay, 1 ground, 2 basement, and we have got 3 normal level floors. Okay, and I have got my 4 colors here. I'm going to use pink to mark this floor as 1. I'm going to use orange colors to mark this one, that one, this one, that one, and this one as 2. I'm going to use my blue colors to mark this one and that one as 3. Okay, and the final color that I have is brown. I'm going to use it only here, and I'm going to mark it as 4. Okay, So now that I have my brown color here, let's write 4 here. Okay, and the name of it is floor on grade. Okay, or ground, it doesn't matter. Okay, and then I'm going to take, excuse me, is this a 3 here? No, that should be a 2. Okay, I don't know why, but I wrote 3 there. Okay, so these floors are all same with each other. Okay, I'm going to take my blue and write 3 here. Okay, and I will write cantilevered floor. Okay, and then I'm going to take my orange color. I will write 2 here. Okay, and I will write here intermediate floor. Okay, and finally I am going to take my pink color. Okay, and I will write terrace here. Okay, don't forget to add floor, 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 and floor words next to them. Okay, so what this categorization is very important. So I know that me and my colleagues, we have asked this always in the exams. That's that important. And what does this categorization tells us? This categorization tells us what layers to put in our floor. Okay, so a terrace floor will be exposed to rain and temperature differences. An intermediate floor will be exposed to impact sound. A cantilevered floor will be exposed to temperature differences, mostly. And floor on ground or grade or ground floor will be exposed to underground water and temperature changes. Okay, so what you need to do while you are working on the design, detailed design of these different floor systems, you need to take into consideration these factors that will affect your floor. Okay, so here are some examples. Let's have a slab floor. Okay, and let's think about the layer organization of it. Okay, this is terrace floor. Okay, and I want it to be a first type of terrace floor. Okay, so they will be exposed to temperature differences and rain. Okay, you have got two options. Okay, the first thing is we usually place a layer of screed here. This is a layer of screed just to straighten and flatten the surface. Okay, and then we cover it with, okay, let's take pink, with an insulation. Of course, this is not that simple. We need to have parapet walls, but we haven't talked about parapet walls or any type of walls yet. Okay, that's why I'm just simplifying it. And then on top of this thermal insulation, you can put your waterproofing. Okay, and that one will be a normal terrace floor. Or alternatively, what you can do is you can have your floor, okay, again like this and like that. This is again a terrace floor. You cast this time screed here, and with those screeds you give a slope, so they can be called a slope screed as well. And what you can do is you can place this time your waterproofing here, and you can cover your waterproofing with a thermal insulation. And we are going to call these types of roofs, these types of terrace floors as inverted terrace floors. Okay, in the roof related lectures you are going to get detailed information about them. Anyway, let's hatch here. Okay, these are for terrace floor systems. Okay, let's move this drawing up, or maybe down, I don't know, or maybe we can just throw it up. Okay, and we can start working on our intermediate floor. Okay, so I will move it slightly there. Again, I'm going to have my slab floor. I always use a slab floor in order to explain subjects related with floors. This time column continues up and down. Okay, and let's hatch this thing here. Okay, and what we do, okay, with this time brown, I'm going to draw some dots here. Let's assume that it is representing the impact sound insulation, and then I'm going to cover it with screed, a layer of screed, and now this is going to be called as a floating screed. Okay, and then I'm going to cover it with, okay, maybe wooden pockets like that, because this is an intermediate floor. Okay, so what do I have? I have my reinforced concrete slab, impact sound insulation, my screed, and wooden pocket, which is glued to screed. Okay, and let's talk about the third type of floors, a cantilevered floor. Okay, let's draw it. This is a beam, that is a larger beam, and that is my floor slab, and here is my column going up and down, continuous like that. Okay, and my beam on elevation and my cantilevered beam. Let's hatch it. And let's say that the top of my cantilevered floor is closed space. So what I need to do now, maybe I need to apply a thermal insulation here, like that. In order to make it temperature proof. Okay, whenever we learn about the external walls, you are going to see that the thermal insulation also continues on top of our wall as well. Okay, this is what a cantilevered floor is. And the floor on grade type of floors, they are floors which are usually located over the foundations. Let's say that this is my basement wall, this is my strip foundation, this is the column in the background. I'm going to draw them more thick. Okay, this is my strip foundation like this. Okay, and here is the dashed and dotted line. Okay, and what do I have? I have strip on the elevation like that. Okay, now what I will do is I am going to compact soil here. Okay, and I'm going to lay gravel, and I'm going to cast the, maybe let's erase this line and transform it into a dashed line. I will have here a slab. Okay, and in order to make it damp proof, what I can do is I can place a damp proof material or waterproof material here, and I can cover it with screed. Okay, and it will be good to have some reinforcement bar here. Okay, and or okay, it will be good to have here a layer of thermal insulation as well. If you want, you can add it there. Okay, and you can cast your screed over that thermal insulation as well. That's the final drawing that I draw. Okay, that's enough for today. So I want all of these drawings to be drawn until next Wednesday. Also, I'm going to shoot a new video about stair systems. So I want that drawing to be watched and drawn as well. Okay, so these are a set of drawings. Reinforced concrete, up here, reinforced concrete slab floor, flat slab floor, hollow slab floor, ribbed floor, waffle floor, steel concrete composite deck type of floor, steel floor with floor panels, categorization of floors according to its places, and the typical sections of a normal and inverted roof organization, layer organization. And I want you to draw an intermediate floor, cantilevered floor, and floor on grade type of floor. Okay, until next Wednesday. Thank you for watching the video. Don't forget to subscribe to my YouTube channel. Bye bye.